The following is an explanation of example 6.5 out of the textbook off of page 252. When a 1 liter solution of 0.1 molar barium nitrate at 25 degrees Celsius is mixed with 1 liter of 1 molar sodium sulfate solution at 25 degrees Celsius in a calorimeter, the white solid barium sulfate forms and the temperature of the mixture slightly increases to 28.1 Celsius. Assuming negligible heat is absorbed by the calorimeter and that the specific heat is equal to 4.18 joules per gram degree Celsius and the density of the final solution is 1.0 grams per milliliter, determine the enthalpy change per mole of barium sulfate formed. This sounds difficult. We need to start out by determining our reaction. Our reaction is between the barium nitrate and the sodium sulfate. We're going to form barium sulfate and 2 sodium nitrates. However, if we look at solubility, this is aqueous, this is aqueous, this is solid, and this is aqueous. The thing that remains aqueous will cancel out for my net ionic equation. So my net ionic equation is barium with a +2 charge, aqueous, reacts with sulfate with a -2 charge that is also aqueous, and we get the solid barium sulfate. Now that we have our reaction written out, we need to remember the equation for calorimetry. Calorimetry is where we're dealing with a change in temperature, typically, with one of these reactions. The calorimetry equation is Q equals mc delta T, where mass, m is the mass of the solution in grams, C is the specific heat capacity, and delta T is the change in temp. And this could be either in Kelvin or Celsius, because when we convert from Celsius to Kelvin, we're adding 273. And if we have two temperatures that we add 273 to, and then we subtract between the two, that 273 just goes away. You can double check that. If you don't believe me, you can verify it. Always a good idea to verify, so that you have your own experience. So, mass. I'm not given any masses. However, I am given 2 volumes. It seems rather simple to assume that when I add 2 volumes together, 1 liter and 1 liter, I will get double the volume. I will get 2 liters, and that turns out to be the case. So our total volume equals 2.00 liters. But I need to get to mass, so I need some way to convert between grams and volume. And it turns out that way I have to convert between the two is my density, 1 gram per milliliter. But in order to do that, I need to convert to milliliters. 1,000 milliliters per 1 liter, and 1 gram per milliliter. Cancel, 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 cancel. We end up with 2,000 grams is our mass. So Q equals 2,000. C, the specific heat capacity. In the problem, we are told to assume that the specific heat capacity is equal to 4.184, which is the same as water. So we're to assume that the addition of this compound has not changed the specific heat capacity too much. And then our delta T is just how much the temperature changed. We end up at 28.1. We started out at 25. That's a difference of 3.1 degrees Celsius. Throw this all into a calculator, and we get a Q equal to 2.6 times 10 to the 4th joules. That is how much heat is absorbed by the water. So heat absorbed by water. However, that's not what the question asks us. The question asks us to determine the enthalpy change per mole of barium sulfate. So we can't actually use this number. We have to use the inverse of it. We have to use, or the opposite of it, negative 2.6 times 10 to the 4th joules is given out by our solution. So we lose 2.6 times 10 to the 4th joules from the solution, and it gets absorbed by the water. Now the other part is per mole, so we have to really think about how many moles we have. Well, we're given some very, very comfortable numbers to work with. We're given 1 liter and 1 molar. That means we have 1 mole. We're given 1 liter and 1 molar. That means we have 1 mole. So we've got 1 mole of this and 1 mole of this. How many moles of barium sulfate will we make? We'll make 2 moles. Or I'm sorry, not 2 moles, 1 mole. Because there's 1 barium on each side and 1 sulfate on each side. And they just nice and easily combine. So we end up with that many joules per mole. And then to convert to kilojoules, we just divide by 10 to the third, and we get negative 26 kilojoules per mole. So the formation of barium sulfate requires losing 26 kilojoules for every 1 mole of barium sulfate formed. Again, this is example 6.5 out of the textbook, located on page 252.